So this is my solution about these two sides being about 2 units or difference of 2. So I looked at this 3, 4, 5 triangle earlier and realized that if I multiply by this 2, then it's going to increase this difference by 2. So you can always obtain composite difference in this way using a slightly early example. But you will also see that this does not recover all possibilities of this one differ by 2. So we're approaching generally. So I write this one as y equals this side y, and the other one is y plus 2, and proceed exactly the same as before. So here's computation. Instead of 1, we have 2. If you square all that and cancel those y squared, you arrive at here, x squared equals 4 times y plus 1. So I'm pulling out a slightly different trick here. So rather than we're looking at this odd number, even number is slightly more structured. So I factor out this common factor and notice that this is already a perfect square. So if you think about the unique factorization property of integers, that forces this one has a factor of 2, and that matches this one. So here's that part. I know because of this 4, I know the x is an even number, so I went ahead and replaced with x equals 2l. So if I replace the 2l to the left-hand side and compare it with the right-hand side and in here, then as we expected, this 2 squared 4 comes out and it cancels, so it becomes this equation. And here it's easy to solve for y, so I will let y vary for whatever it is. Or actually, the way I did it is I realized it doesn't matter what L is, as long as L is something, y is going to be always. So I still use this L as a free variable. L can be anything, and therefore then we can easily solve for y. So here it is. I let this L equals k and plug it in here and solve for y. That is k squared minus 1, and x was 2l, and L can be anything. That makes perfect sense here. So 2k, and z is 2 more. So if I add 2 there, you get k squared plus 1. So this is new parameterization, so where these two things are always 2 units apart. So I used the Sage to calculate some examples. So here are some examples. And we recovered somewhat as for 3 and 5. It happened to be 2 units apart, so you could have swapped around. I could have noticed that earlier. That's a lot easier way to look at it. But this one came from this 3, 4, 5 multiplied by 2. So this units are 2 units apart. But if you look at this one in here, and you can see this is not coming from multiplying 2 to some earlier solutions. This has no common factor. And 15 has 3 and 5. But none of those factors divides this 8. So this is so-called primitive solution. There's no common factors to these 3 solutions. This is a good source of the solution we're looking for. Oh, I wasn't aware I was recording. So but here, so that so another one is 12, 13, 35, and 37. I don't think they have a common factor in here. 37 seems like prime numbers, so that's another one.